Okay, continuing in chapter 21, section 5, alkylation of enolates. All right, as you might expect, enolates like this one, and I've drawn the negative on the carbon. Again, you can draw your enolates however you want. You can use a carbon-carbon double bond and an O minus. You can put the negative on the carbon. You need to understand the resonance between the two and the fact that they represent the same structure. Okay, well, they're strong bases, and it turns out they're good nucleophile. Remember, strong bases tend to be good nucleophiles. So if you have an appropriate SN2 substrate, right, we can alkylate that. There you go. So we just made that carbon-carbon bond. I talked about this, I alluded to this a little bit in an earlier video, maybe the one on enolates. So strong base, good nucleophile. The trouble is, they are really strong bases. Okay, so if we have a substrate that's got beta carbons, beta hydrogens, right? There's no beta carbon and there's no beta hydrogen on methyl iodide. So any SN1, SN2, E1, E2 substrate that doesn't have beta protons, you can use to alkylate an enolate pretty well. So no beta hydrogens. SN2 is good. But where there are, so if we used ethyl iodide, let's say, instead of methyl iodide, now what you'd expect to see, and what you actually do see in abundance, is elimination. Right, you just get E2 chemistry. E2 is really common. There's actually some other complicating so I don't want to get into this a lot. There are also some other complicating reactions that can come up when you have an enolate and an alkyl halide. Really, to summarize this, all right, so if the electrophile has beta hydrogens, the SN2 is going to be poor because you're going to see E2 and some other stuff more often. There is a way around this. Called the malonic acid or the acetoacetic ester synthesis. They're related, and I'm going to go through, I'm going to put up the summary right here, but I'm going to go through it in detail in a couple of other videos. So remember that enolates of dicarbonyls, this is still a really good nucleophile. It's a much weaker base than a single carbonyl. So the dicarbonyl enolate is a much weaker base than the single carbonyl enolate. And so here, if I treat this dicarbonyl enolate with ethyl iodide, I'm going to get a good SN2 reaction here. All right. Well, that's great, but it doesn't, if what you want is to alkylate a single carbonyl enolate, that doesn't help you a whole lot. Except the malonic acid and acetoacetic ester syntheses give you that workaround. There's a way to convert this to what would be a single carbonyl, and for that, you have to have one of these be an ester or a carboxylic acid derivative. Okay, so in the next two videos, I'll show you how that works.